In this lecture, we'll be talking about the last type of equation that we're going to be working on solving in this class, which are multi-step equations. We've done one-step equation where you only have to do one thing to each side to solve for the variable. We've done two-step equations where you have to perform two operations to both sides of the equation, and now we're going to do multi-step equations, which could take a couple different approaches as we go through. So you'll see. So I feel that the best way to handle multi-step equations is not to have a whole bunch of steps, even though it's called multi-step equations. It's more to have a checklist. So what we're going to do is we're going to use this, like it says, as a checklist. You might not have to do this every single time, but you should be checking this every single time. And if you don't need to do it, you go on to the next step. If you don't need to do that one, go on to the next step. So some of these are going to look familiar because they're steps we've already got down. You're going to see things that look like the two-step equation, the one-step equation, and so on and so forth. Okay? So first things first, we want to simplify both sides of the equation. Simplify, as we've learned, means we're going to remove parentheses using the distributive property and combine any like terms. So if you've got parentheses that can be removed using the distributive on either side or on both sides, do that. And if there are any like terms on each side, combine those. So if you've got 2x and 4x on one side of the equation, squash those together and make that 6x if they're being added together. So step one would be make sure both sides of the equation are as simplified as possible. Don't worry about combining one side to the other. Just on the left and the right, are they as simplified as they can be? So that's step one, simplify both sides of the equation. Step two, we want to get all the variable terms on one side of the equation and constant or just plain old numbers on the other side. And we're going to use inverse operations to do that. We're going to add or subtract really more specifically. But we want all the parts of the problem with variables, with letters, to be on one side, and the numbers, plain old numbers, on the other. Again, it doesn't matter which side is which, as long as variables are on one side, constants are on the other. And then undo using addition or subtraction, or undo, and this might be an or situation, then undo using multiplication or division. So undo multiplication or division. Really, once you get to step two, it's more often than not going to be a one-step equation. And then we're going to go through a couple here so you can see it done. But that is, that's the checklist. Simplify both sides of the equation, get all the variable terms on one side and the constant terms on the other, and then undo addition or subtraction or multiplication or division, depending on what you have left. And usually, once you get to step two, you're going to have you're more often than not going to have just a one-step equation. So let's take a look at some of these types of things, these types of problems, and use the checklist as a checklist. Okay? Pause this video at any time if I'm going too fast or if you need to catch up. That's the beauty of these recordings. You can pause me at any time. Okay? So again, there aren't any new notes on this one. That's important to know. There are no new notes on this. It's just examples, so we just have them here. But let's take a look at this one. Let's run through the checklist. Are both sides simplified? 9x. There's no like terms over here. There's no like terms over here. There's no variables. There's no parentheses to get rid of. Boom. Are all the variable terms 9x only on one side and the plain old numbers on the other? Check. Okay, so we're down to steps 2 or 3 or 4. Since this is a multiplication problem, we're going to divide both sides by -9. X will equal 9. That's a one-step equation. We didn't have to do steps 1 and 2. because they were already done for us. Let's try this one. Again, let's go through the checklist. Are both sides simplified? Well, this here, 3x plus 7. There are no parentheses to get rid of. There are no like terms that we can combine. There are no, I don't know what I was doing there. There's only the number 49 on this side, so both sides are simplified. Now let's get the variable terms. This is one where we have to say, okay, and now it's a two-step equation. What do we do with two-step equations? Well, we minus 7, so 3x is equal to 42. And now we're down to, hey, look, we're down to a one-step equation again. And x is equal to 14. But again, we didn't have to do step one. We did have to. We had to get all the constant terms, because in this problem, 3x plus 7 equals 49. We had a constant term on both sides. We had 7 and 49. These are constant terms. They're not going to change. It's always going to be plus 7 or positive 49. This term, this part of the problem, will change depending on what x is. And you can probably see where this is going here. Oh, look at this one. We've got a unsimplified left-hand side here. We've got to get rid of these parentheses, and what a dirty trick that is. We have to distribute a fraction. Well, one way to deal with fractions, remember, multiplying by a third is the same as dividing by 3. So one way to do it is to say, I'm going to do this. I'm going to multiply this side of the equation by 3 and this side of the equation by 3. So these will all, 3 times 1/3 is 1, which is just the same as having nothing on the outside of the parentheses. And then, since I multiplied the left side by 3, I'm going to multiply the right side by 3. I also could have done circles and rainbows if I wanted. That would have worked as well. Then, I've simplified both sides. I'm going to subtract 12 from both sides, just like we always have when we're doing two-step equations. Negative 18 minus positive 12 is the same as negative 18 plus negative 12. So that's negative 30. And divide both sides by 6. Divide both sides by 6. X is equal to negative 5. This is one where we've got multiple things we have to do. We have to simplify. We have to combine like terms. We have to get all the variables on both sides, rather, and that sort of thing. And I think that maybe we have one more. Oh, we do have one more. All right. This is another case here where, are both sides simplified? Yes, both sides are simplified, right? There's nothing here on this side that we can combine or use the distributive for. Nothing on this side we could use the distributive to deal with. So we're straight to step 2, which is getting all the operations on one, getting all the variable terms on one side, the constant terms on the other. I would always recommend, where are there more variables? There are more x's on the left-hand side. There are 7 x's over here. There's only 3 over here. So what I would do is subtract 3x from over here. We don't want the x's on the right-hand side. We want them on the left-hand side. 4x plus 20 equals 44. And now we're at a two-step equation. It's kind of important that we can do those two-step equations, because that's really where we get to when we solve a lot of these multi-step equations. Now we've got a simplified, they're simplified on both sides, but we have constant terms on both. So I'm going to subtract 20. I'm going to subtract 20 here. That's 4x equals 24. Divide both sides by 4. X is equal to 6. So we have these steps in place. We have this checklist in place. We're not going to worry about that for right now. We've got this checklist in place that will allow us to solve equations that have variables on both sides, that have unsimplified expressions on both sides, and it's something that we can ultimately use to solve any type of equation. I didn't give you this right off the bat because I didn't want to overwhelm us, but really now that we've got practice with one-step equations, practice with two-step equations, having this checklist in place can be like the only thing. It's kind of like a Swiss Army knife. It's a utility tool. It'll work for everything. We're going to get plenty of practice on solving these types of things. These might be challenges. These might be challenging, and that's okay. We can still always check your answer. You can still always plug answers back in and see if you get a true statement. So that's solving multi-step equations. We're going to get plenty of practice in class. Let me know if you need any help. I hope this video helped.